I think there's some really cool synergies and parallels when we think about what makes AI and machine learning work and what makes it useful and valuable and produce beautiful things. What is that like for offsite construction in comparison to all of construction? So I think that's really kind of the foundational parallel, I guess, that I see, which I think is pretty cool. And then we can build on that, right? And then really figure out, so how do we turn that into something real?
Let's hop into it, Lucas. Why is offsite construction the perfect candidate to lead the way in adopting AI for construction?
Yeah, so I think what I realized, and it actually took me a little bit of time of really understanding and getting that into this industry, was there's a couple of what I think are pretty cool parallels when you think about AI and specifically machine learning need and use, and when does it thrive and when does offsite construction thrive. And a lot of it, when you think about machine learning and AI, it's all about patterns, right? And picking up patterns and making use of them and deriving value from that. And really what at least I and we believe is that there is a lot of synergies and overlap, because one of the most important things that we can do, right, to help not just offsite construction scale, but also construction as a whole become more efficient and more productive, is leveraging patterns, figuring things out, how to take things that are repeatable and scalable and yet remain beautiful and useful and do all of the things that we want buildings and architecture to do, right? So I think there's some really cool synergies and parallels when we think about what makes AI and machine learning work and what makes it useful and valuable and produce beautiful things. And what's that like for offsite construction in comparison to all of construction? So I think that's really kind of the thing that foundational parallel, I guess, that I see, which I think is pretty cool. And then we can build on that, right? And then really figure out, so how do we turn that into something real?
Maybe you could help us understand, to include myself, AI in general, very new.
Yeah.
Really, it's like the 2023, tech of the year. AI came out, ChatGPT, all these things.
Exactly.
I don't think really people understand it yet. So, is it going to take your job away? I guess is the question, Lucas. Everybody says AI will get so smart that we'll all be we'll be taking orders from our computers someday. But yeah, in all honesty, though, how does it fit into what you're doing? And then it'll be great because we're going to show some demonstrations of what you're up to.
We're all about AI this year, basically, end of 22, 23, like you say, ChatGPT was all the rage and continues to be all the rage. But AI as a thing has been around since the 50s, right? So basically the first time that the term AI was like a thing was, I think, in 1956. One of the big US colleges, there was a professor that was like, oh, let's figure out how to teach a computer language. And that professor thought that was going to be like a summer project, right? Because how hard can it be? Turned out it was pretty hard. And now what is it? 70 plus years later, there's this next wave, because we've seen these AI waves before, and it's super interesting and super cool because of the generative part, right? So you have different types of AI, different types of machine learning that solves different types of problems. So you have classification, right? Somebody gives you a text and says, oh, this text is about politics, this text is about movies. Then you have things like clustering. You try to group things into things that are somehow similar. And we've been doing these things for ages, right? You look at recommendation engines on Netflix, that's been a thing for ages. You have some form of machine learning underlying that. Mm-hmm. But then when we talk about generative AI, what's so cool about it is, like we said, that generative part, right? That creates something new. And then now we're starting to see how good this actually is getting. Just taking vast amounts of data, in the case of ChatGPT, basically captures all of that information, distills it into this model that then can generate new output from having built a model that has ingested all of that information, and then abstracts away from that, turns it into this what's called deep neural network. It's basically just a bunch meaning billions of connections and parameters where you throw the input in, and then that builds up this ability to take and abstract away from what the algorithm has seen in the training data, which is basically all the text in the case of ChatGPT, and helps you produce new output. And now you have this model that can do stuff, and then also taps into actually live data from the web. And now we get to do some really, really cool stuff with that. But it's basically capturing a lot of historical data, identifying and capturing all of the patterns in some shape or form, and being able to then generate new output from that.
It's amazing to me. And how do you capture all this data? Do you have to put in the billion points of data into these systems, or is this something that's growing on the web that you can just kind of source a lot of this information?
There's typically a couple of steps to how you would do this. So what you would start with, and that's at the moment at least still super expensive, tons of compute power. So you like run like these clusters of servers basically somewhere in the cloud, sure, but it is still servers, physical servers, right? And I mean, one of the reasons OpenAI is burning this much money as they are currently is one, they have to train these models, which for the big language models that OpenAI and ChatGPT are based on, it's in the orders of millions of dollars just to capture all of this data, then train the model, which is capturing all of the underlying patterns and basically training this neural net, which is a bunch of neurons. Each of them has like a weight side to it. And then what we do as end users is you would then call that inference or the generative step, right? Where you take the model that has been trained, and then when you actually ask ChatGPT a question, it doesn't have to retrain anything. The model is now trained, right? So then each query still consumes some data, but it's not like you have to train a big model from scratch. And then this other thing that people do is called fine-tuning. That's where a lot of people now think the real value will be captured, right? Because ChatGPT has scraped all the data from the internet, but it's open, right? So in theory, everybody has that data, but then you can take this model that has kind of learned this generic representation of the world, and then you can fine tune it. Say you have some really cool proprietary data set, like say you're a health tech company and you have access to this data set that nobody else has access to. And then you can basically fine tune this algorithm that ChatGPT or that OpenAI have built, and then you can fine tune it to your own domain. And then it becomes particularly good at this one task, and we can then start to envision similar tasks for, say, construction, for example. With these smaller data sets that are, however, like very specific and only you have it, that's where a lot of people now see actually there's going to be a lot of value creation that's going to happen.
Well, I appreciate the background on this. So Modulize itself, right? You consider yourself a marketplace. Explain that, and then let's get into what you actually do, and maybe we'll get to some of those demonstrations.
Basically, what we're building is a marketplace for offsite construction, right? So what we saw when we started this was this massive opportunity with offsite construction, and however, also there being some challenges that are real roadblocks in us thinking and talking about massively scaling offsite construction, right? And one of the big ones that we saw was actually basically the intersection between the contractors, the builders trying to adopt offsite construction, and the manufacturers who produce the building elements, produce the modules, be that timber frame, be that light steel frame, precast concrete, or full modules. So across the spectrum, really, we saw that there was a ton of friction with the contractors trying to figure out how to use offsite construction, and the manufacturers getting actually their product to the contractor. Because in Europe, there is this setup where offsite construction on the manufacturer side is mostly dominated by kind of SMEs, right? So they might be producing certain types of elements using one type of material. So in, say, Norway, there's a lot of timber frame manufacturers. And then as a contractor, especially as a kind of mid-sized or larger contractor, you might have a bigger project where you need timber frame walls, you might need precast concrete. You also want the bathroom pods, say it's a hotel. And then you have to go out and try and figure out who could be a good supplier, who could be the right supplier for this particular project. Maybe I've worked with somebody else before, but they don't have the capacity, they're not a good fit. So, and then the process, the whole tendering and procurement stage of a project is just a massive pain as well, because it's still super analog, lots of back and forth, emails, phone calls, SMS. And so what we're trying to do is basically build a stack of tools, both for the contractor and the manufacturer, to kind of manage and run their side of what's a typical kind of tendering and procurement process, and then connect those two so that we basically connect each contractor for their project to a network of manufacturers on the supply side that we can then figure out, okay, who's the best supplier for this particular project, so that we can really start to streamline and remove a lot of the friction that we see in the procurement stage that gets to the point where we've seen tons of contractors that actually look at offsite construction and go, oh yeah, we should be figuring out how to use it, but this is too painful, so we're just going to stick to on-site because we know what the numbers mean, we have historical data and all these kinds of things. There's so many reasons to then not make the jump, and that's really what we're focused on, so building the connective tissue between those two.
So, really, what does, the role of standardization play in scaling offsite construction? And then I'm sure you're going to weasel in some of this AI and ML talk with it as well.
Offsite construction can do a lot of things, but when we talk about like scaling this whole thing, we need to also talk about a couple of different aspects of standardization, right? And I think we really want to look at two points when it comes to standardization. One, the standardization of the actual thing that we're building. So if we can, and this audience will know this, right? Because we're all about offsite construction. But as we get to a point where we call it mass customization or something else, right? As we get to a point of figuring out how to build things that are good quality, that are beautiful, but that are based on things that have some level of repeatability, right? If you're gonna have this building, maybe don't look at having to build wall elements that are, one is 11.2 meters wide and the next one is 11.4 meters wide, right? So having this degree of repeatability and standardization of the actual physical products that make up the building is one thing. But then the other thing, which ties in a little bit more with kind of the data side of things, so on the more in the digital space, is that we also, for us to really make this scalable and repeatable and use the power of data, then we also need to talk about standardization there. And one is adhering to and using standards. Like, for example, we talk about IFC as a format, which is super flexible for representing your 3D models. And sometimes it's a little bit too flexible, right? Because you can basically put in anything. So there's these efforts around standardizing what good practices look like for using IFC to represent 3D models. But then, and that's actually then almost throws us straight into one of the other topics that you mentioned at the start, which is around like learnings from other industries. One of the things that me coming into the industry was actually a little bit shocking was the lack of kind of driving towards open standards, because that's the added layer, right? So we can talk about standardization all day on the data side. If those standards get implemented based on closed ecosystems and closed proprietary formats, very quickly you get into trouble, right? And if you look at, for example, the banking industry, they've adopted open standards much more aggressively, and it just creates all this opportunity. So I think there's some really important lessons there and some really important points for us to, in this industry, actually get to a place where we can leverage data much more efficiently. So that's why I think there's really these two important discussions that need to be had around standardization. One is directly relating to offsite construction and the physical product, and the other one is it's a much broader kind of construction industry point, right? Because it's not just offsite construction that struggles with the adoption of standards, and also especially the adoption of open standards and high quality and consistent adoption of that.
And we talk about this quite a bit on the show. Are there learnings from other industries that we can adapt to the construction industry itself? Like, can you take what you were talking about with standardization, what's happened in other industries, and is that adaptable to our industry?
I think the easiest example is actually banking, right? Where you have the open banking standards, even though you have the kind of channels like MasterCard has their own thing, Visa has their own thing, and then all the different big banks have their own systems, they still pretty much operate on a common protocol. You can now just build, fintechs have a much easier time than construction tech companies, right? Because they can plug into something where they know what they're plugging into. There's a clearly regulated way of a standard being implemented. It's not proprietary, so you don't create this lock-in, right? Whereas in our industry, maybe if you want to pick certain standards because they have the biggest reach, there is often comes with a degree of lock-in, right? And then you build, say, us as an early stage startup, it's pretty dangerous to tie yourself to a standard when it's a proprietary standard, because you have little to no insight into how that's going to evolve over time. Is it going to be supported in 5 to 10 years, right? So there's a lot, I think, with what, and like you can think about banking and finance what you like, right? But a lot of the things there, they've actually gotten right. And I think those lessons, I think, should translate into construction and the built environment in general, so real estate just as much.